All right. Thank you very much, ladies and gents, for joining us on this snowy February day. It's the first day of the month and the second McComb meeting. Usual ground rules, please mute yourself if you are not speaking. We will do the officer reports, subgroup reports, other things like observing reports for the good of the club, segue into In the News, followed by our short talk, and then take a little break before the main presentation. So, as your president, I'd like to thank you all for joining us tonight again. We have exciting news. Our mailer, 2020 Year in Review 2021 in brief, with an appeal to join the club and the Astronomical League, if you like, is on its way to all of the members. So, Publications Director Dale Teamy and Jonathan Cade made sure that that went out. So do check it out when it arrives. We also have an update on the calendar snafu. As I said in an email to y'all last week, there was a publication error on the back end of our club calendars that affected the US and Canadian federal holidays. Since the printing company made that error, they will replace the calendars. Please let us know via publications@warrenastro.org if you want a replacement calendar. Again, it's only the US and Canada federal holidays, all the astronomical data, club meeting, picnic dates, and of course the pictures are perfect. It's just missing, Memorial Day, Labor Day, Christmas, Canadian Thanksgiving, that sort of thing. So again, send us an email, publications@warrenastro.org, to request your replacement calendar if you are so inclined. We'd like to have a turnaround by the end of the month, so we'll be cutting that off after the next McComb meeting. Finally, we've got, it's not an intra-club event in the usual sense, but our comrades at Seven Ponds are on the list to be invited to virtual events from Palomar Observatory. And in the spirit of comradeship, they have invited us to participate in a virtual event hosted by Palomar that celebrates Mount Wilson and its historic telescopes. So that will be 2 o'clock on Friday, a virtual event via Zoom. I'm sending out the invitation with the Zoom link to all of you on our mailing list on Thursday. So that'll be coming out to your mailbox, and just join if you're free on Saturday and you want to take in a really cool lecture about Mount Wilson. So we're trying to do some more reciprocal events with Seven Ponds and our fellow regional clubs, even if it's all remote. So thank you very much for that. And with that, I would like to pass things to our first Vice President, Dr. Dale Parton.
Thank you, Diane. Excuse me. At our next meeting on February the 18th, our speaker will be Dr. Ilyas Cholis, who teaches astronomy at Oakland University. His topic will be antimatter cosmic ray physics. Then a month from now, on March the 1st, we'll have 2 presentations that concern Mars. The Perseverance rover should have landed by then, so how appropriate. So first, Gary Ross will give the short presentation entitled "The Case Against Mars." Then our main speaker that evening will be someone whose name you may not have heard for a long time, Dr. Gilbert Levin. He was the lead scientist on an experiment to detect life on the Vikings, using the Viking spacecraft that landed on Mars way back in 1976. His topic will be, is there life on Mars? I would add that I'm always interested to have people volunteer to give presentations in the future. So if you have either a long presentation or a short one to offer, please let me know. Thank you much. Diane, back to you.
Thank you, Dale. And I'd like to pass things now to our second vice president, Observatory Chair Riyad Mati.
Thank you, Darren. Hello, everyone. I visited the observatory this last Friday, January 29th. Both buildings are in good shape. We don't have any problems. All the equipment is fine. And of course, in the meantime, we continue to not hold the open houses because of COVID. One reminder, though, is that during these open houses, if the weather is good, if the sky is clear, and if Doug Bach is available, we are still holding the virtual open houses. And those are a lot of fun if you attend. Doug talks about his equipment, he describes his software, he answers any questions, and he also either has a list of items to look for that evening, or he sometimes also will take requests for objects, and if they're available and can be reached, Doug will try to observe them with the rest of us. So that's all I have for now. Thank you.
I would like to add that sometimes special guests chime in from wherever they are outside, or might be freezing up, trying to their own observation or imaging. So it can be a fun time when that happens.
That is true.
Just throwing that out there. It was me last.
Yeah.
Right.
Thank you, Riyad. And let's pass things to Secretary Mark Kedzier.
Good evening, everyone. The minutes are in the February edition of the WASP. That's all I have to report. Thank you.
Short and sweet. Thank you, Mark. And that means we go right now to Adrian, the treasurer.
All right. We are currently still transitioning. We've set some dates to do that. I'm going to go real quickly with what we have. We're sitting in our main account at $21,388.56. There are plenty of pending deposits you've all sent, and we are in the process of processing those. So there will be an update to that number throughout the month. The GLAC account has $3,375. I've included a deposit that we know is coming for that GLAC account that we received from Dr. Brian Ottom. Our PayPal account has $664.65. Your memberships have been counted in there, those of you that send through PayPal, and we encourage those of you that can to please continue using our PayPal account. It's quick and efficient and gets you updated as a member much quicker than the traditional check method. But we will accept checks if you prefer to pay those to our PO box. And memberships, I have 152 memberships. And again, we will be updating based on the renewals that we have. We will also be checking on the memberships that are lapsing and send out a kind note. We do have the mailer that's being sent out.
Yep.
For those of
That's
you,
the kind note. So the kind note is on its way to everybody.
Yep.
Whether you've paid up or not.
And if you haven't paid up, please do. We are kind, and we know that it's COVID, but if you could pay up, please do that. So that's all I have for my report. You can chat me on the side if there's questions about renewing memberships or anything else, and I will try and get back to you as soon as I can get your messages.
Thank you, Adrian. And I did post the link to both the Join Us page from our website that has the PayPal link at the bottom of it, as well as the link to subscribe to our mailing list if you have not done so. So that'll make it easy. And now let's go to Bob Tremblay at Outreach.
Evening, everyone. Outreach has been a little light in the past several months for obvious reasons, but a couple of our members are taking to doing online stuff. Ken Burton reports to me that he gave a presentation online for Centennial College And he converted all of his miles to kilometers. He did his size and distance. He says with questions, 52 attendees. It went on for over 2 hours. They had zillions of questions, and that's really cool. I gave a presentation to my wife's astronomy class about the Perseverance rover. It was an entry-level presentation, not nearly as detailed as our last meeting's presentation. And I will be giving that same lecture for the Detroit Public Library on the 16th at 6 p.m. Other than that, as I said, outreach is a little light. If anybody wants to do online stuff, please let me know.
Yep, you can always send your outreach adventures to outreach@warrenastro.org. So Bob puts it down in the report. And with that, let's go to Dale Teamy at Publications.
Well, the WASP is up. We got that up yesterday. And of course, you know now the mailer, our semi-annual mailer has gone out. So we're caught up there now.
All right. So as far as our subgroups go, we've got nothing really happening on the sun. I can share a link with y'all to Soho. I don't see Captain Solar Marty with us tonight, but there's really nothing to report. Here you go. There's the link. You can check it out. We do have Bill Beers from Astrophotography would like to talk to y'all. Bill, take it away.
Hello, everybody. This really doesn't have anything to do with astrophotography, but I thought it was pretty important. Since the majority of our members are seniors, I highly recommend, can you see this right side up? I highly recommend you all get vaccinated. I was vaccinated last Saturday at Beaumont Hospital. It's a very simple process, very well organized. No side effects. And what I really want to share is myself and most of my friends have been having trouble getting scheduled for an appointment. So what I found was if you call the Beaumont number, I mean, you've probably all registered and have not heard back. So my suggestion is call this Beaumont number, then hit extension 1 and go right to extension 2, then you can bypass all that other stuff. You're going to be put on hold for at least an hour. I was on hold for an hour and 10 minutes before I finally got through. Then you just explain to them you want to schedule a COVID appointment, and they're very accommodating. So I highly recommend it that you do that if you've been having trouble getting through. And what's cool about it, if you do a good job and you don't cry while getting your shot, they give you this really cool pen syringe. So I highly recommend everybody getting a shot. That's the only way we're going to get by this crap. Does anybody have any questions on that?
No age restriction, is there?
Could you put that phone number up again?
Sure. Right now, what they're doing is age 65 and over.
So
St.
Can you just read that number? We can't really see it on the screen.
It's 800. I'll read it. It's 800.
1-800-592-4784.
And Doug Bach has kindly copied that into the chat so that y'all can just copy paste that at your
Perfect. This is for the Beaumont Hospital. They do it in Southfield and in Dearborn.
Yep.
Keep in mind, you're going to be put on hold for at least an hour. So put your phone on speakerphone and set it down and go about your business.
St. Joe's is also accepting people.
Yep.
St. Joe's of Pontiac. They also take that's one that you might want to go to and get the form that you do. Linda and I have had our first shot already, and they're very efficient as well. So there's a lot of places around that are taking care of people. So St. Joe's of Pontiac.
I've found from what I'm hearing that, everybody registers and they're not hearing back online. So
okay, we have a lot of questions about the vaccine thing. This is important in the sense that in order to get back to actually meeting in person and observing together and doing outreach. Everybody's going to need that. But we do have three presentations left to go. So if you have questions about what time of day, who to call, other things, take that up in the chat or take it into the while we do our break.
I was just going to say, Diane, let's do it at break time.
Yeah, let's do it at break because I see there's a whole lot of questions. So
Yep.
thank you very much for that PSA, Bill, because you're right. If we want to get back to doing outreach, that's where we got to go.
Good.
Okay. History group, I believe you're good for anything was in WASP. History group.
I was looking at all the questions.
Okay.
The one thing the WASP I wanted to point out was I was digging around in my directories the other day, putting the WASP together, and came across a bunch of images that I scanned from one of our former members who passed away some time back, and I had gotten a hold of those pictures, so I scanned them in. I sat in the directory, and I thought, well, I'll just put them in the WASP and see if anybody recognizes anybody. And I've been getting some hits, so I may continue that practice. I got more pictures to go through.
All right. And Astronomical League.
I have been talking to the Astronomical League about the current status of things, and the best way to get into the Astronomical League for next year is to pay your dues renewal and pay the extra $7.50, and you'll get the wonderful Refractor magazine on a quarterly basis.
And the opportunity to participate in their observing contests. All right. So that should wrap up the subgroup reports. We've got observing reports next. David Levy is first in the queue, but I just wanted to mention in passing, I don't know how many of you have seen the March issue of Sky and Tell. If you read their cover article on the dimming of the star Betelgeuse, you might have noticed a familiar name in the article. Jerry Persha, based mostly out of the Grand Rapids area and the GR AAA before he moved elsewhere, contributed data that is in Sky and Tell. So that was interesting reading a familiar name, flipping through the article. So yeah, amateurs are still out there doing work, variable stars that gets in real publications. And David, I know you wanted to go first, so.
Thank you, Diane. Can everybody hear me all right? Okay, great. The observing here in Vail, Arizona, well, probably better than it is in Michigan, hasn't been too bad. Their sunspots are showing. There haven't been any sunspots, but a lot of prominences lately, and some really bright complexes of prominences. And so that's been very good. No real meteors, but I did have a major event that took place just the other night. I recorded observing session number 22,000. And I started recording my observing session. Session 1 was October the 2nd, 1959. It was an eclipse. And there were a few lettered sessions before that, but now up to 22,000, and I'm still observing and I'm still recording. I hope we have a good meeting tonight. I'm sure we will. My welcoming quote to all of you is from Leslie Peltier. And I did give a lecture about comet hunting just a few nights ago. It'll be on the Astronomical League's website in a couple of days. And but here's my quote. What Leslie Peltier had to say about comets. Time has not lessened the age-old allure of the comets. In some ways, their mystery has only deepened with the years. At each return, a comet brings with it the questions which were asked when it was here before. And as it rounds the sun and backs away toward the long, slow night of its aphelion, it leaves behind with us those questions, still unanswered. To hunt a speck of moving haze may seem a strange pursuit, but even though we fail, the search is still rewarding, for in no better way can we come face to face, night after night, with such a wealth of riches as old Croesus never dreamed of. Thank you. Back to you, Diane.
Thank you, David. Love Leslie Peltier. All right, more observing reports before we go into In the News in the Sky. I think we have a couple of people. Mr. Blum, I see your hand is up.
Well, it was too cloudy to observe anything outside, but right here inside, I observed a wonderful column written by our illustrious president in the current issue of the WASP, where she beautifully describes her relationship with her friends, the stars. So if you have not read Diane's column in this month's WASP, I think you should immediately leave this meeting, go online to the warrenclub.org website and read it.
That's so sweet of you, John. I think I'm blushing, but thank you. Anyone else? Going once, going twice at the observing reports?
So I do have a.
All right. Let's hear it, Adrian.
I'll brief
Or
share
see it.
if I could.
I assume that there's images attached.
There are images attached. I'm just gonna go ahead and share the screen, and this has got to work. So let's see. I think it's sharing, so now I have to. My lighthouse shots. It worked. Uh-oh.
It's coming. It's low. Here we go. I see lighthouses.
Okay, see it. Okay, so all right. Try and observe. And what I saw, this way, rise, would be expected to pop up. So I was I wouldn't shut myself out. So I took some pictures, and I'll just like this one a little bit better because you can see. So Orion and Taurus make an appearance above and near the lighthouse. And this is at sunset. The sun light. There was not much time between astronomical twilight. Of course, we couldn't see much of moonrise, so I could still get a pretty decent shot of
Your audio's gone on the fritz, Adrian.
Yeah, I thought maybe that was just me.
I'm seeing some beautiful pictures, but the audio's gone to bits.
Gone.
okay. All right, I'm able to hear you. Okay, so I'm back, I think, and so that was my observing. Try doing some imaging from home, and with my other camera, I was able to get the very few days that we had clear. I was able to do some imaging at Orion. However, if you were able to attend Doug Bach's show, you probably saw a few better images. And if you were able to attend Brian Adams' show, he did a pretty good show around Orion as well. His show was last night, I think at 9 o'clock. And he did a pretty good, he did a great job actually with his, both Doug and Brian did great jobs with their online imaging. I went out into the cold and stuff and took as good a pictures as I could, considering the circumstances, but I'm going to have to go back and another whole moonrise thing again. And let's hope somebody doesn't buy something so that it sends clouds my way instead. That's my report.
All right. Anyone else before we go to In the News in the Sky?
Diane, I have a quick observing report.
Sounds good.
Probably the first week of January, we had a clear night. It was way too cold to be outside with the telescope, so I was geeking out here, and I actually put William Herschel Symphony No. 8 on the YouTube, and I had my binoculars and a sleeping bag in front of my sliding door window. And I thought, you know what, Mars is out there somewhere. I'm going to grab the Sky Safari and see where it's at. And then lo and behold, as I was zooming in, Uranus was like right there, nice and close. And there was a nearby asterism that kind of was easy to star hop over. So I had my trusty 10 by 50 binoculars, and I'm 90% sure that I was able to find Uranus pretty easily with a pair of binoculars. And it didn't even dawn on me until I was like looking at it that, oh my gosh, William Herschel, I'm looking at Uranus. How cool. How geeky. That's my observing report.
Love it. And leave it in the chat. He wants to remind everyone that Thursday, February 4th, the Global Star Party and Astronomy magazine will celebrate Clyde Tombaugh and his 115th birthday online. Cool deal. All right. I think we're ready for Bob to do In the News in the Sky for us. Bob?
Righty, let's do this share thing here. Alrighty. Do you see a rover?
I see a rover and I see a Father Christmas in a wonderful costume.
Alrighty, so yeah, first picture here. Mars Perseverance lands February 18th. Very excited. I gave the presentation to my wife's classroom, and the kids were really excited about the helicopter and the microphone. So that's pretty cool. So the kids got engaged. But anyway, it lands on the 18th. The rover is a technology demonstration, and it will be the first attempt at controlled flight on another planet. So, and you can read all about that in our latest newsletter. Happened today, the International Space Station had the second spacewalk of the year. Astronauts Mike Hopkins and Victor Glover Jr. conducted a spacewalk to finish battery upgrades and install high-definition cameras outside the ISS. This is the second spacewalk for the duo in just a matter of days. It began at 7:56 a.m. and lasted 6 hours and 56 minutes. So that's that one. This is pretty cool. Astronomers find a possible exoplanet in the making within its own whirlpool. On January 21st of this year, an international group of scientists led by researchers in the Netherlands announced they found what they think is a planet in the process of forming inside its own vortex or whirlpool of dust and pebbles. That is, they're seeing not just a gap in the disk, but an actual world being born within its own planet-forming maelstrom. So here's an artist recreation of what that might look like. The exoplanet count as of yesterday, the number of known exoplanets is 4,341, and we have 2,453 candidate exoplanets. That's yesterday's count from the NASA Exoplanet Archive. Smile. This is a recent image from the HiRISE camera on NASA's Mars Reconnaissance Orbiter. Shows Gale crater, not to be confused with Gale crater, also known as the Happy Face crater for obvious reasons, but this one has snow. And I got to thinking when I saw this picture, I said, where is that on Mars? And so I cranked up Space Engine, and it's right in the middle of Mars there, and so there's Valles Marineris up at the top there, and a pole at the bottom. So that's where your Happy Face crater is on Mars. This next story is pretty interesting. Astronomers have found the biggest black hole ever measured, 40 billion solar masses. That's roughly 2/3 the mass of all the stars in the Milky Way galaxy. This monster is a result of the merger of multiple galaxies. So, yikes. This black hole lives in the center of Holmberg 15A, a supergiant elliptical galaxy at the center of the Abell 85 galaxy cluster. Galaxy lies about 700 million light years from Earth in the constellation Cetus. This story actually punked me. I was looking around for stuff, and I saw this. Astronomy Magazine tweeted this yesterday, right, January 31st, and so I go there, see the story. It's really cool, and then I noticed that it was published in February of this year, and I'm like, oh God, I hope somebody else didn't already cover this. Too late. I'm covering it again anyway. So scientists chart shifting colors of Comet 67P's season. I'm like, wow, that's pretty cool. So the European Space Agency's Rosetta spacecraft was the first to orbit a comet as it circled Comet 67P Chermov-Gerasimenko from 2014 to 2016. Rosetta's up-close look at 67P has given scientists an unprecedented chance to understand what these small icy worlds are like. So now a team of researchers has unlocked another one of those comet secrets. As the comet goes around the sun, clouds of gas and dust billow and settle, surrounding the comet in a haze of shifting colors, visible to telescopes, binoculars, and cameras. Oh, next slide, please. Oh, that was supposed to be going. So different parts of the comet tend to reflect different colors of light depending on where the comet is in its orbit. And the researchers have figured out that seasonal cycles of dust and ice on the comet are causing these color changes. These scientists are presenting their findings in Nature on Wednesday. The researchers looked at more than a year of data from the Virtus instrument and found that the wavelengths or colors of light in the comet reflected changed as the comet got closer and further from the sun. As the comet approached its closest point to the sun, the atmosphere or coma of the comet got redder while the nucleus appeared bluer. Then, when the comet moved further away from the sun, its coma got bluer while the nucleus got redder. Pretty interesting. Diane asked me to comment about NASA's director departing. And Jim Bridenstine did an adequate job, I guess, of being the politician at the top of NASA. As far as I know, he did not gut the agency like a fish or attempt to dismantle the agency from within. For the most part, I never thought about him very much. However, I do remember a lot of concern about him being a climate change denier when he was appointed. I also remember about a week after he started, he tweeted that after talking with NASA scientists, he now believed that climate change was real. However, he never mentioned it again, and I find that a bit disingenuous. If he did indeed believe that climate change was real, he would treat it like an emergency. He did not. The Biden administration has appointed Steve Jerzik, I hope I pronounced that right, as its acting NASA chief on January 21st. Jerzik has been the agency's associate administrator since May of 2018 and has worked at NASA since 1988. If the current trend of Biden administration appointing highly qualified individuals to government position holds, I'm pretty sure I'll approve of this next NASA administrator. And tonight, looking for something about this guy, I found this thing, this tweet from Futurism, right before the meeting started, so I haven't had a chance to listen to this interview. I will be doing that after this meeting because I want to find out about this new NASA administrator. So, going to In the Sky. Playing around with Stellarium, I noticed that there's going to be an interesting dance of planets over the next several days in the east-southeastern sky. Jupiter and Saturn reappear, and they do this dance with Venus. Mercury joins the planet party. And what's really interesting is right about there. It's interesting to note on the 16th, Jupiter, Saturn, and Venus all align along the plane of the ecliptic And there's Mercury, and you can, from this vantage point, you can definitely see, Mercury's orbital inclination is highly evident. But unfortunately, you're not going to see any of this because at the time this happens, that's what the sky is going to look like. So this whole dance of planets thing that's going on is happening in the light of day. Sorry. Maybe the SOHO satellite will get a shot of it. So something that you can see at 6 a.m., the waning gibbous moon is going to be in the southern sky, and it's going to be near Spica on February 3rd and near Antares on February 6th. Whipping around the Earth, coming back in the west on the 13th, it's going to appear in the western sky at dusk, and it's going to get higher every day. And it'll be near Mars on the 18th, and it'll travel across the sky and be near Aldebaran for a couple days between the 19th and the 20th there. So that's the moon this week. Last quarter moon occurs on the 4th. Again, you will see this moon in the early morning. Next week, not so much. So if you're a deep sky imager, this is the week. Next week is the week for you. As has been mentioned, the sun is boring. Spaceweather.com says it's been spot free for 4 days now. But the Solar Dynamics Observatory can see in different frequencies, and there's been some interesting prominence activity and coronal loop activity. These are from this morning. So that is in the news in the sky for February 1st, 2021.
Thank you, Bob. Much appreciated. The planet dance had missed my attention. I'm usually on top of that. So.
Well, I said I had to turn the atmosphere off. That's
I'm
seriously hoping that SOHO catches that. That would be very cool.
That would be awesome. All right. Well, thank you very much. If you're interested in putting your own personal spin on In the News in the Sky, contact me or First Vice President Dale Parton. We can get you signed up. In the meantime, I will now turn things over to First Vice President Dale Parton.
My window go. How do I stop
to introduce the first presentation of the night.
Thank you, Diane. So our short presentation tonight will be given by Bob Berta. I think most people in the club know him. He's been a member of the club since 2004. He's held various offices, including being president. And he's a member of the Oakland Astronomy Club, the Seven Ponds Astronomy Club, even the San Francisco Amateur Astronomy Club out in California. Very briefly, Bob had a career working as an electrical engineer out in California. He's a musician, a cyclist, a kayaker, and is very active with scouting groups. And on top of that, he and his wife managed to raise 5 children. So I've always heard that the Yerkes Observatory north of Chicago had the world's largest refractor. Apparently, Bob disputes that. Bob, why don't you tell us about that?
Okay. Can you all hear me?
Yes.
Okay. Switch are you picking up my video?
We have your video, but not your presentation yet.
Yeah, okay, good. Okay. Like many of you always thought the Yerkes telescope, the big refractor, was the ultimate refractor. But actually there was a larger refractor built, and the Yerkes probably would have made a good finder scope for this scope. It was a telescope that was built for the Paris exhibition of 1900, and it was not designed to be really a useful telescope. It was designed to be more an example of what the technology of the day could build. And this thing was truly a monster telescope. Let me, if I could share my screen here. I've got some pictures of it. Okay. Let's see on here. Can you see that?
Nope,
you-
not yet. You have to hit that up arrow at the bottom of the WebEx window that says share.
I did do that, I thought. Let me go back.
I don't think.
Okay.
I think you probably had to click on something else in addition to whatever you clicked on.
Oh, okay, here we go. And it should be just a screen one. There.
There we go.
Yep,
It's
now we get it.
Okay. Well, this telescope. Okay, got it. Okay, well, this telescope was truly a monster. It had a 49-inch aperture, which is compared to the 40-inch on the Yerkes. The focal length of this monster was unbelievable. It was almost 200 foot long, which is three times as large as the focal length of the Yerkes refractor. And you might say, well, how the heck did you ever aim this thing? And you couldn't aim this. What you had to do was mount this giant steel tube on pedestals that went the whole length of this large building. And then at the end of it, one end of it would have this device, which was actually the focal assembly, which allowed you to travel back and forth 5 foot to focus it. The other end had the device at the bottom lower of that picture. It was a chelostat or statostat, whatever you want to call it. It was also could be used as a heliostat for solar viewing, because this was designed, it could be used visually as well as photographically. You know, the photographs of the day were probably pretty hard to get compared to modern days, but you could do that with this. It might have been a little bit difficult because the focal length of this thing was so long that the f-stop was only f45.6. So some of you who are refractor nuts, I know Riyadh and myself and a couple others are really into these type of telescopes. This thing was pretty amazing. The lowest power of this telescope was 500 power, 500x. That was the lowest power. And the widest field of view was 0.05 degrees. And they had 2 sets of optics for it. They're both achromats, I believe, and one was set up for photographs. The other one was set up for visual observing. The siderostat at the bottom left here of this picture, the idea is since you couldn't move the telescope and aim it, this device would reflect whatever you want to look at off this giant mirror into the telescope. So that's how you would work it. Okay. Surprisingly, or not unsurprisingly, I guess, there were several scientists who did want to use this, and there were a few scientists who did use it, and they actually got useful photographs of both sunspots on the sun, as well as one fellow got some, well, at the day he didn't know that they were actually galaxies, but you know, nebula, but they're actually galaxy. He got 151. So there was some scientific work, but unfortunately, what they found out, which is obvious, is that when you have something so monstrous, people misinterpret what it was designed for. And so he became the subject of a lot of scorn. You know, the Don Quixote building this telescope, which was a giant telescope, really unusable. Well, in reality, it had good optics. But what happens when you take a good optic and put it in the middle of France, in Paris? Atmosphere, the crowds, light pollution, everything else. So obviously it didn't provide great images. But later on testing, they found out actually it had pretty good optics on it. If there's some way you could ever get this thing out away from all the lights. Okay. Unfortunately, the guy who came up with this great idea, he had a problem at the end because, well, what I'll do is I'll sell this thing and recoup some money. Well, unfortunately, because of things like this newspaper, which called it liken it to Don Quixote, they said this thing is a waste of money, waste of stuff. So nobody bought it. So unfortunately, this company this guy had, as a result, went bankrupt. So that was the end of that telescope. Some of the scientists on this telescope actually believed that there was life on the moon and life on Mars, and he used the telescope for a while trying to prove, in fact, that there was life. Unfortunately, he wasn't able to, of course, but that was one of the reasons this telescope was hopefully used in the scientific community of the day. This was started in 1886, but it was for the 1900 Paris telescope and Paris Fair. A couple of the people that used it was Antionati, who was one famous scientist, astronomer. Another one that used it was the, if I can find it here. Another name of the guy here. My pages here. Okay. There. Antonelli and also a Charles Lamorvan. And those were actually published in the Strand magazine, November of 1900. So actually pictures, photographs from this telescope were published. So despite not being a practical telescope, it did meet some of the requirements, I guess, for a scientific instrument because it was published in the Strand magazine. The telescope itself obviously no longer exists as the tube, but the optics and the siderostat are still in storage at the Paris Observatory or Paris Museum. It's near the Eiffel Tower, I believe. So that's the end of this talk. But anybody have any questions about this? If you want to learn more about it, you can look it up on a few YouTube sources. The most likely one you'd want to find is at the excuse me, the Wikipedia. They have a pretty good article about it. Not a whole lot of photographs of it because obviously in that day photographs weren't particularly fantastic. But I know Riyadh would appreciate that. And back of this picture, very back, that's your film magazine. So you can imagine how big the sheet film would have been for this thing.
Yeah, a few feet by few feet.
Yeah, pretty large hunk. And you can imagine trying to run that stuff through your developing trays. Anyway, and I think David, if he's still listening, I want to give a shout out to David because I've been to his house along with my good friend Linda Mahan and her late husband Norman. And like David, who names all of his telescopes, I name my telescopes. And one of my telescopes I actually inherited from Norman Mahan, who I know David knew him. I named it Norman. So Norman is one of my newest telescopes. So hi, David. Okay, that's end of my talk.
All right. Thank you very much for that, Bob. That was enlightening. Anybody have any questions for Bob before we cut to the break?
Bob, I got a question on the optical flat. It must have been much bigger than the diameter of the lens, right? If you tried to look at anything near the zenith, it would have you'd be looking at an ellipse. So.
Yep. Yeah, you're right. You're right. So the pictures probably were distorted because when you're taking it at an angle like that, it could be distorted a little bit. But that mirror could be set up at the, I guess, 90-degree angle, 45-degree angle, whatever. So you could probably somewhat optical correct the the distortion of it. But I don't know what they did in those days. They're probably kind of pretty limited about what they could do with this thing.
All right, and Riyadh had a question also.
Yes, Riyadh.
Riyadh?
Sorry, I was muted. I was told in the past that because this lens was so large and relatively, of course, would have to be thin, that the gravity basically deformed it, and it was not very useful because of that. They could not really point it upwards anyhow because the center would sag so much.
That's correct. In fact, a lot of people don't realize a lot of the big refractors have that same problem. And what they would have to do on these big refractors over a period of time is rotate the optic in the cell to allow for that sagging of the glass and over time from gravity's effect. Hey, any other questions? Yeah, I think
if there's no more questions, thank you very much, Bob.
Okay.
Hey, Bob, how many elements?
Just two.
The lens, or was it two elements? Yeah. Okay.
Acrobat, 2 elements. Well, and there were 2 sets of optics, as I said, one for photographic use, one for visual. Okay.
All right. Well, we can take a 15-minute break. Grab your drinks, grab your snacks, and then we'll come back here at 8:35 for our feature presentation of the night. So thank you very much, Bob.
Very fun talk.
Yes, and we'll see y'all in 15.
So I see we have our feature presenter, Professor Castoldi here. Would you like to do any sound checks or anything?
What do I do? Do I just click on the share to share my screen, or you do it?
No, you would have to do that.
Okay, so let's try.
Sure.
Okay. And then I guess so.
You got it.
You see it? I don't.
We got it. It looks great.
Yeah.
Well, can you put it into the slideshow mode though? Because sometimes we have had problems with that. Not so much on Windows, more on Mac.
So should I? But I don't need. Okay, hold on.
Just start the presentation, and that'll fill the screen.
Because what I'm seeing is get Cisco Webex. Sorry.
It says the Kuiper Belt Objects and demoting of the.
Yeah, but I
Pluto.
don't see it. Okay, so maybe now okay, all right. So I go on my screen here. All right. So and you see that, and so now you see it.
There you go.
Screen,
Perfect.
right? All right. So just give me the go. Okay, I'll be here. You tell me when to start.
Sounds good. I think we were going to start a little bit early, so about 8:35.
Okay. Okay.
All right. Sounds great.
Yeah.
It looks good.
Yeah. I'm ready. Okay. Can
All
you
right,
can
excellent.
hear me
I'm
well?
We can hear you good.
Yes, we can hear you perfectly.
Okay, great. Great. Thank you. Okay.
All righty.
And I need to borrow your driver's license when I get my shots.
What?
I think Victor was looking for a space ahead in the vaccine line.
Yeah. Anyone want like, you guys senior enough? Can I borrow your ID or whatever?
I think the actual seniors need to get the vaccine first. So.
Yeah, it's too bad it's 65 and over.
I don't think they let you double dip, so let's not cheat anybody out of their dose.
I have a late observing report. I sort of joined the meeting a little bit late.
Go ahead.
We'll go ahead.
We're in the break right now, so
yeah,
everything goes.
So, my first time imaging in about 6 weeks, or actually, I think it was 7 weeks. I had one clear night and went out and had almost the whole night where I could image, and I got this California nebula. Can everybody see that?
Yep.
Yes.
Yeah. Okay. And so I used a new small refractor. It's actually a camera lens for this. A new little wide field setup. So that's sort of my first light for that new setup, and also a smaller mount. So it's essentially my portable rig. And I can change the lens out for other focal lengths. This is wide. This is 135 millimeters with the APS-C camera. So, and this is actually cropped.
Dale,
California Nebula is
filter on
huge.
that?
The wide field is even larger. So what was your question?
Did you use the L enhanced filter?
L Extreme.
Okay.
It's not very efficient at f2. I have an IDAS NBZ filter on order, but they are, like everything, back ordered. And that is supposed to work far better at fast focal ratios, like for my Hyperstar as well, which is about the same.
Nice image.
Yeah. So this is 2.5
that
hours of integration.
A half hour?
2.5.
2.5. Okay.
5-minute frames. I think I kept 30 frames. This red up here is actually like it going into the trees in the house. So it's actually not a nebula up there in the top right. I cropped out a lot of stuff. So
Was that, you said you used a 135 millimeter? Is that a Rokinon?
it's a Samyang, also known as a Rokinon.
Okay, yeah, I've heard of those lenses. I heard they do really good work for astro imaging with these cameras.
Yeah.
And they're not too expensive compared to, say, you tried a Canon L lens.
That's my little setup.
That is such a cool looking setup. I mean, that is just
so it's 8
like
pounds, grab and go.
You could build a suitcase for that and take it with you on trips really easily.
Well, I'll probably go to Harbor Freight and get one of those plastic little like hard cases.
Big Pelican, yeah.
Now, what are you mounted on? Are you mounting it? What mount are you running it on?
Okay, so I got an Ioptron CEM 25P. Okay. I got the last one that High Point Scientific had in stock. And this is after they were discontinued. Someone actually had, I don't know, returned it, but it was unopened because I had a different, I had a UPS label under mine. I got North Carolina. So it popped up in stock. I bought it, and then I've never seen them again. So there's a new model coming out of CM 26, slightly different specs on it. But it's the first time I used it. I've had it since October. But I got it specifically for this small model. So this is a William Optics thing that comes with the Red Cat. ASI Air Pro to control it with my iPad. This is electronic focuser from CWO. And this black piece I 3D printed, designed myself too. It's similar to others, but this is unique to this one. This riser is 3D printed. This piece here to hold the TP-Link router, little mini router, and its power supply is 3D printed. Nice. And underneath here, I have a little adapter because this is offset. I couldn't screw into the primary hole. I had to go to the secondary one. So, and this piece here, this cogged piece is just friction fit onto that to match up with the belt.
So you could, so that's how the autofocus mechanism works.
That's right. So ASI Air has an autofocus or manual focus as well. And that worked well. So I'm pretty excited for this. I can swap out any Canon lens. Now, if it doesn't fit into here, I'll have to mount it differently.
Yeah.
I have a 300 millimeter I'd like to try as well. I used it once on my Sky Guider with a regular Canon camera, but I haven't used it with my Astro camera.
Bill?
What was that?
Is that the 294?
2600 color. Oh.
Okay. So it's a color one-shot camera?
Yeah. APS-C. It's fairly large.
Okay.
Yeah.
Yeah, 1.5.
So this guide scope, I didn't even know these were out there. I have a couple of them, different ones, but it's $50 on eBay. It's made by SV Boney, but it looks the same exact specs as the ZWO one, which is like $100. I thought I'd give it a try. It seems to work fine. This is a 178 MC. So it's a fairly high-res planetary camera that I'm using. It guided well, especially for the focal length of the guide scope is 120, and the focal length of this, it's supposed to be 135. My software says 130 is measured.
Well, at that focal length, you probably don't even need the guide.
I probably don't, but by doing that, it gives it the ability to dither.
Yep.
So without dithering, I'd get walking noise and stuff like that, which I've had in the past. So
I tell you what, I can dither just on my own.
I dithered, but I didn't drizzle. But I sometimes drool. So.
Oh, that's a really.
So this is a project I've been working on. The design and thinking it out for a while, and I'm just happy to get it out there and start using it.
And yeah,
So I'm taking pictures here. I'm going to post it on Thingiverse and share my design so others can do the same for these printed parts. So build your own. I got the lens for $270. I got more money in the cameras. The cameras. This little camera costs more than the lens, so the guide camera's more. So that's kind of funny, but maybe ironic.
It's a smart investment. That's a nice sharp picture. The manual focus lenses are always.
I use that lens for some portraits for our official family portrait for our calendar.
And came out nice. So. It's all about knowing how to use the lens. The off-brand lenses are a real good way to save, and your aperture can be just as wide as the as the big name lenses. Even if you try to go Sigma or Canon or that, you're spending a lot more money for what ultimately would be similar performance. So
I got this lens specifically for astrophotography based on reviews. It's a nice super wide focal length from astronomy standpoint. For focal, it's kind of a zoom lens. And not zoom, it's a telephoto lens for regular portraits and so forth. So it performs very well, flat field, apochromatic. There's no false colors, sharp corner to corner within reason, especially at APS-C size. Virtually no coma at this field of view. So, I mean, it really does well for astronomy. So that's my share. It's fun to go out and observe. Now, setting up this new mount and getting it polar aligned with my fingers freezing, it was like one of the coldest nights of the year. It got down to 4 degrees, but with this little Wi-Fi extender here, that little white thing there, I had the iPad inside the house, and this was outside. So it was the first time I could really control it from the inside now that I have that extender. So that helps.
That's a smart way to do it.
Yeah.
And I happen to know your skies. I was up your way.
I saw that. Passed on up to Pornop Arts.
Yep. And it was cloudy, and there wasn't enough time between astronomical twilight and moonrise to really see in the darkness that I know that place can get. So we just missed it. The sky started to get the stars started to show up, and then they started to disappear. So, but it was still.
Here's my observing buddy.
Oh, look at that.
He was looking through the eyepiece, but there's no eyepiece, so he just sniffed the camera.
Well, he may have been after Sirius. So I actually had, Diane and I had a visual observing report that we thought we had given, but we think maybe we didn't. We were walking back home from just a midnight walk, which we tend to do so we don't run into people. And we noticed that the sky was clearing, and that night happened to be the night that Uranus and Mars were close, as close as they got to one another. So we got home and pulled out the refractor, since we didn't really have time to let the reflector cool down, and got a pretty nice view of the two planets together. And even from Dearborn, Dearborn helped by hiding all of the stars that were not Uranus or whatever that other star in Aries is that is a similar magnitude. So it really narrowed it down nicely. But I don't know if anyone else got. Mark, did you say that you got to see that too?
Totally.
Somebody had mentioned seeing the conjunction of those two, but
yeah, I did. It was just with binoculars, but yeah.
So I saw on YouTube on Chuck's astrophotography channel just today that he put up a video about an ISS transiting the moon, and Chuck is in, I think, Livonia. He's in Detroit region. I didn't realize this region was going to have that event. Not that. It's always cloudy, it seems. But he didn't put the exact date down that he captured it. So just because he posted it today didn't mean it wasn't a month ago or something. So were any of you aware of an ISS transiting the moon?
I was not.
Not at all.
Although, they happen. It happens fairly often because if it's not up in the nighttime, it's often up in the daytime. So
Yeah.
Several
point on the
times,
Earth, though, I mean, you might have to wait, I'm guessing, like once every couple of years? Or do you think it's more often than that for any one point on the Earth?
I feel between the sun and the moon, we've had at least 5 ISS transits of one of the two over the last 4 or 5 years.
Yeah, that fits my recollection. But
So
I believe we need to reconvene and get things rolling with our long presentation for the night. I see. What? So if everybody, barring Dr. Dale Parton and our guest presenter, could mute themselves, I will turn things over to Dr. Dale Parton to introduce our featured speaker.
Okay, thank you, Diane. It is my pleasure to introduce our main speaker for tonight, Professor Kapila Castoldi. She has a doctorate in high energy physics from the University of Milan in Italy. After 10 years as a research scientist at the Italian Institute for Nuclear Physics, she came to the United States, joined Northwestern University for experimental work at Fermilab. Professor Castoldi eventually joined Oakland University, where she now teaches astronomy. Her topic this evening is the Kuiper Belt Objects. Professor Castoldi, welcome.
Thank you. I hope you will enjoy this. As I was preparing this talk, I sort of started digging in the history. And so anyway, so I hope that what I'm saying makes sense. So of course, the discovery of these Kuiper Belt objects is also related to the demoting of Pluto that some of us, studied to be one of the 9 planets. And, anyway, so to begin with, I like to go back to the year 2006. That was a crucial year for astronomy.
I'm sorry,
Professor Castoldi.
We don't have your slides up right now.
We don't have your visual feed coming.
Okay, sorry. So let me go up 1 second. So how do I do it? Escape here. So let me go back. I thought I was sharing. Oh, probably I got out of the sharing. Oops. Okay.
Yeah, you've got.
Okay,
Here
okay,
it comes. Here it comes.
Now
Very
you
good.
see it.
Now we've got it. Thank you.
Okay. Okay. Good. Okay. So sorry. And so anyway, you see here the title, it's the Kuiper Belt Objects, but also linked to that is the demoting of Pluto. And so coming back to the, as I was saying, the crucial year 2006, in which our solar system suddenly changed. We knew of the existence, of this series of planets, and actually forever, for hundreds and more, throughout the history of Earth, the first 5, planets surrounding Earth were known. But it took a long while, though, to scout some of the other planets. So as we will see, Uranus, that was not discovered until the 1800, and so on and so forth, and Neptune, and eventually Pluto only in 1930. And just to get an idea, this picture is to scale, so we can see how far Pluto is and how small it is. So no surprise that it took forever to notice it. And as I was just saying, the 2 of the large planets of the so-called Jovian planets are Uranus and Neptune, that were really late additions to the solar system. And the reason is very simple. They are very slow and they are very far. So they're large, but they still are not easy to detect. And so one of the two, Uranus, was discovered sort of by accident back in 1781. And then in the meanwhile, studies of, the gravitational attraction of planets and the orbits of the various planets made people understand that there were certain perturbations in the orbit of Uranus that were not explained by the existence of the known planets. And so Adams and Leverrier both hypothesized the existence of yet another planet in somewhere out there. And so it took quite a while. So it took until 1846 for eventually discover Neptune. Both Adams and Leverrier made predictions of roughly where in orbit that object ought to be. And their predictions were not perfect, but somehow with some search, Neptune was eventually discovered. And yet, as they kept doing these calculations of the gravitational attraction of this planet, they still were not satisfied because Pluto is pretty small. And so, when eventually it was discovered, again, it took a long time because it's extremely slow and also very, very small. And so, even then, when in the equations, the mass of Pluto was placed, there was still not enough mass that could account for, the orbit of the outer planets. And so here began the hypothesis of a planet 10. And I'm not going much into that, but just leave it there as, one question mark that we still have. And, why did it take forever to discover Pluto? Well, this couple of images taken about a week apart show how pretty difficult it has been to, see this distant object. And it takes a while. The best way is to focus on the two brighter objects nearby the arrows. And so notice the change in position of Pluto, in between the two photos. So once again, very difficult to detect, but also keep in mind these two pictures because we will refer to these back in a while. And so, of course, the question is anything else out there? And so I want to just show a couple of slides about the solar nebula model of the formation of the solar system to make sense of the existence of objects all the way out there at the outskirts of the solar system. And so, of course, we are fully aware solar system. Of course, there is the star at the center. To the star are rocky planets, followed as we move progressively farther away from of icy planets, but also there are, according to the theory, what we would call overs from the formation of these planets, which are asteroids and comets. So this is kind of the family that we have known for a long while. And so coming very, very, very briefly to this solar nebula, the solar system started like a very large nebula. Nebula, it's a Latin word for cloud. Gases, primarily hydrogen and helium, which are the gases that were formed, with a big. And dust, where does this dust come from, is recycled from the life and death of many other stars that happened before ours. And so, the model to function needs to have this nebula already rotating, even if slowly, but some initial rotation must have been there, caused by what we don't know. But as you know, the action of gravity began to contract these gases and dust, is a phenomenon that I always, you know, remind my students is similar to those who make pizza. You know, they spin it around and the dough flattens. So in a similar way, because of conservation of momentum, this nebula gradually flattened, and to make the story short, hottest part was at the center, which eventually became the sun. But the surrounding disk eventually, because of multiple collisions, began to accrete, you know, areas that formed the protoplanets and then eventually the planets. But not all of that material completely you know, was able to be completely absorbed in the planets, and so there were some leftovers. And you begin to see from at the bottom of this figure that, you know, the two distinct regions happen simply by, you know, because of physics, basically. So the part closer to the sun, where there is warmer temperature, at these locations, only metal and rocks can condensate. And therefore, here is the region where the terrestrial planets or rocky planets formed. As we go progressively farther away, we go to regions where, you know, which are below freezing, and at these temperatures, ice, you know, could begin to form. And here is where the Jovian or Jupiter-like planets formed. And so coming back to this is kind of an enlargement of the picture where this frost line is, you know, depicted. And so within the frost line, any remnants that did not condensate, once again, you know, as the larger planets formed, we know that the first 800,000 years or so were, you know, all these objects, you know, were encountering an enormous amount of collisions, and therefore some, because of the effect of gravity, we believe primarily because of the effect of the large mass of Jupiter, some smaller objects were scattered and fragmented, and these formed the asteroids, excuse me, that are rocky, just like the terrestrial planets, that formed in this region inside this frost line where rocks and metals could condense. And conversely, in the region outside that frost line is the region where still we had these other leftover fragments, but this is where at least for the longest time, we've always known that icy comets forms. But of course, that's the region where we are finding now many other objects. And so the asteroids, as I just said, are rocky leftovers. They are primarily between Mars and Jupiter because, once again, the strong gravity of Jupiter caused collisions and disrupted the formation of another planet. And if you notice, there is actually a very large gap between the orbits of Mars and Jupiter, and therefore a planet could have formed there, except that most likely we believe that Jupiter is the culprit that prevented that. All these asteroids are small and have a total mass that is only 1/1000th of the mass of the Earth. So it's not a whole lot that is out there. Yet there is lots of these, and they still cause collisions, and the ones that come too close to the Earth become the meteorites that you know, we know of, that occasionally strike. I mean, the very tiny ones strike on an ongoing basis, but larger ones have been striking the Earth on, you know, on and off throughout the history of the planet. And here is a description of, so all these tiny white dot representing the locations where asteroids have been detected. And as you can see, they form truly like a belt between the orbits of Mars and Jupiter, but not only. If you look a little carefully, you see that they come all the way to even within the orbit of Mercury. So some of these asteroids we have to live with and hoping that they don't come too close to us. And then you may see, I've drawn these kind of orange lines at 60 degrees, before and after Jupiter. These are the Trojan asteroids, which share Jupiter's orbit, and they are locked in this position by some what we call a resonance. So it's a very peculiar story. As we will see, we will talk in a while about how Pluto was demoted, and one of the reasons is that its orbit is not clear of debris. Well, Jupiter has this debris, but it's accepted that, of course, it is a major planet. But also these debris are in these particular locations that will never interfere with the planet itself. They are kind of locked in orbit along with it. And of course, we have nowadays, we have had missions to the asteroids and that visited the two largest ones, Ceres and Vesta. And other missions have also brought back photos, close-up looks at these, bombarded also objects, mostly with totally odd shapes. The only ones, that we know of that are the two largest are Vesta and Ceres is actually, spherical. It resembles minimally, the moon or Mercury. With its own craters, but is also pretty small. It has a radius of only 293 miles, so it's a small object. And so this is all, materials that the Dawn mission has given us, provided us. Then the other remnants are the comets that, once again, are in the region in which, we have primarily ice. So comets have been defined as dusty snowballs. And of course, they're small, they're icy. And very interestingly, though, they belong to two different regions of the solar system. One that eventually became known as the Kuiper Belt is beyond the orbit of Neptune. And it's a region, of objects that are in orbits that range between 30 and 100 astronomical units. And these happen to orbit pretty much all in the same plane as the planets, not completely, but the majority does. But then there is this other huge region, which extends to 50,000 astronomical units, like a big sphere surrounding the whole solar system, in which other of these comets belong, and these have very random orbits. So the comets that we see repeatedly coming by the Earth are the ones from the Kuiper Belt. The other, if we see them once coming nearby, and then their orbits are so large that we'll never see those again. And here again is a depiction of that. So fairly, systematic, type of orbits in the Kuiper Belt, and then all these random orbits in this huge region surrounding the sun. And as you know, we have had a few missions to comets in recent years, and these are spectacular images from the Rosetta mission that show truly how pretty much, pretty odd objects, the core of these comets, but it shows also the evaporation beginning, as the object reaches the closest distance to the sun. And then there are, other very beautiful photos, but this is just to see, the difference between, the core of a comet and the asteroids. And so we believe that under the action of the large outer planets, so not only Jupiter, but also Uranus and Neptune, many of these objects have been deviated highly. And so we believe that the Oort crowd was formed by these planetesimals were the beginning, the seeds around which planets formed, but in this case, that never materialized as planets. And these were the ones between Jupiter and Neptune. And instead, the Kuiper Belt was formed by these planetesimals that are beyond the orbit of Neptune. These were also called initially trans-Neptunian objects before they got the name Kuiper Belt Objects. And these are, larger than the ones in the Oort crowd, and once again more aligned. Most lie on the ecliptic, on the same plane of the orbit of the planets. And so we discovered eventually that Pluto is most likely just one of these objects. And so a couple of words about Pluto. Of course, it has an orbit that is very elongated. Now, coming back to a little bit of history, we know that it took Kepler a long time to formulate the laws of planetary motion, simply because he could not detach himself from the idea that was accepted at the philosophical level, that the orbits of the planet must be circular, must be perfect, and therefore circular. So it was only when he finally realized that the orbits, he tried actually the elliptical form, that everything matched. And so when it comes to Pluto, his orbit is odd compared to the orbit of the other planets. The other planets have orbits that are, except for Mercury that has a more elongated orbit, but the orbits of most planets are nearly circular. That's why it took so long to Kepler to visualize. But Pluto has an orbit that varies between categorizes it as a little different. Of course, it's very far, and so it has an extremely long period, about 248 years. The other oddity is that while the orbits of the other planets are all lined up with the ecliptic, the orbit of Pluto is inclined by 17 degrees. And it's also a little bit odd because it's not this, it's not that. It's not a terrestrial planet because it has a density of 2 grams per cubic centimeters, while the terrestrial planets have a density of 5.5 grams per cubic centimeter. But it's also denser than the Jovian planets that have a density very similar to the density of water, of 1.5 or so grams per cubic centimeter. So it's kind of an in-between. But also yet another issue, Pluto's orbit intersects Neptune's orbit. This is not true for any of the other planets. And the last issue is that it has a huge moon, Charon, that is 2/3 of the size of Pluto. Now, of course, we live on planet Earth that has an oddly, a large moon, but not that large compared to the planet. So all these, made us think. So here again is kind of a rendition of the orbit of Neptune and the orbit of Pluto that is inclined. And I always, remind my students also the fact that don't worry, there will not be a collision, because their period of rotations are so different. And once again, the orbits are at an angle. Here is a picture of Pluto in foreground, and in the background is the moon. That gives an idea how oddly, how odd this very large moon is, and gives also an idea of the icy world that, but also with this red region. What is that? Is surface rocks. So these are all taken by New Horizons when it reached, Pluto in 6 years ago, 7 years ago. And so here, yet another thought to add to what we just saw, that in the 1950s, Gerard Kuiper, from whom then this Kuiper Belt was named, argued that the solar system should not come to an abrupt end. And so this simple graph shows the orbital speed of the planets versus their distance from the sun. And so we see that, where Pluto is not really the end of the story. So it looks like there is room for something else, beyond Pluto. And so we add this thought to the whole story. And then the major discoveries. Pluto is not alone out there. So it was in 1992 that the first object that was only 130 kilometers in diameter, or about 90 miles in diameter, was discovered at the outskirts of the solar system. And so there the search started, and by early 2000, we had actually found a few of larger size, among which one eventually named Aries, that is the same size, or actually touch larger than Pluto. And we have seen, in this search, we have seen that some of these objects have their own moon or moons. And so eventually this region was named the Kuiper Belt. And by now, so about 30 years later, we have detected some 2,000 of these objects, but we estimate that there may be up to 35,000 that, of course, we will need slowly to look into. And so the presence of this belt, of course, explains the existence of the comets that live in this region. And also, as I mentioned already, these are primarily, at least the bulk of these objects have a circular orbit, some elliptical, and actually a few and completely irregular. I'm not going to go in detail, you can study this more in detail if you're interested, but this is a rendition of the orbits seen from above, and then, from the ecliptic, that shows the orbit. Orbits vary from circular to elongated, but also said, although most on the ecliptic, some as a reminder, has an orbit that is inclined by 6 degrees. So it's all pointing to the fact that Pluto, is probably one of these objects. And so here is our now interpretation of this second belt of leftovers that are beyond the orbit of Neptune. And the names you see here are of some of these objects that were found. And the yellow line, we'll come back to that, is the orbit of the New Horizon mission that touched Pluto and now is going beyond. And so once again, you can see that the it's a very large region and populated by many Yes. Now, of course, the question is, we found some large size ones. We want to find more. We want to study more. And so I'm sure you are much more expert see. I've utilized these in experiments that were looking marvels that this type of techniques give. They are 100 times more sensitive to light than photographic plates. And so looking at objects this distant, we need, this type of techniques. And so to summarize the search for these Kuiper Belt objects, the idea is very similar. So we come back to those two photos we saw of Pluto. Okay, this time Pluto was observed at about 1 week distance, one from the other, and we saw that little tiny spot moving. Now the search for these Kuiper Belt objects is similar in a way, except that in this case, 3 photos are taken 90 minutes apart. And of course, because we are scanning such a large area, it cannot be done by eye, but we have computers that scan photos for some moving spot. And of course, then those that are detected are manually scanned to confirm that there are no mistakes. And the one in particular shown here is the detection of signal. So it's a fairly much automatic technique, but still it takes a long time to scan all the region surrounding the solar system. And so just to give an idea, I put at the bottom the size of Pluto and the average distance from the sun, and then also the size of its moon. And so we see that in the early 2000s, we found other objects that are either the size of the moon or even Eris. Of course, the exact size of these objects is not known. They need to be observed larger Pluto from the sun, comparable to the distance that Pluto has, and of course, its moon. So one of the early ones detected, and then and here they are compared to Pluto, to Eris, which was okay, and then which we just saw, and then in the picture are placed also our moon and Triton, which is the larger moon that Neptune has, and also once again looking at the sizes, it's very likely that Triton was one of these objects that was then captured in orbit by Neptune. So most spherical, but some a little more odd in shape. And so here is the making of the the molting or the fall of poor Pluto. At the August meeting in 2006, the International Astronomical Union created this definition of planets. A planet is an object that, of course, is in orbit around the star, but not around any other planet. That's plain and simple. But also, it must be large enough that gravity has shaped it in a spherical form. And so objects that are too small are of the shape of a potato or whatever. There was not enough gravity to make it into a spherical object. so it must be reasonably large. This is what I was told. It must have cleared its orbit of other debris. And typically all the planets have, we have seen there is this exception of Jupiter, but it's a different story. It's a mathematical resonance that is happening there. And so Pluto failed the third of these criteria in that its orbit is full of chunks of some of these icy objects. And so this new definition of dwarf planet was created, and so Pluto was demoted to dwarf planet, and at the same time, objects that are large enough to be spherical and have their own orbit, clear from other objects, etc., were promoted to become dwarf planets. And so the largest asteroid, Ceres, and the Ares, one of these KBO's objects, were now elevated or promoted to the role of dwarf planets. And so by the result, with the result of this meeting, basically the solar system changed. So we don't have any more 9 planets, but only 8. And then, there is Ceres that is not even visible. It's so tiny that, anyways, in the asteroid belt, that is a dwarf planet. And then in the Kuiper Belt region, Pluto, and what used to be called, catalog number 2003 UB, whatever that is Aries, that are now dwarf planets. But of course, the story continues. And I was mentioning before, the New Horizons mission is helping us looking more into this region. Of course, the findings of New Horizons will be limited because its primary mission was to reach Pluto, but the mission has been extended to look around a little bit more. And we will most likely need a new mission specialized for the Kuiper Belt objects to look a little bit more in that region. But one of the interesting findings was that we had already found that beside Charon, Pluto had 2 other moons, Nix and Hydra, reasonably small. But then with the coming of New Horizons in the neighborhood, these 2 other moons were found, which are really, tinier than the tiniest, not even 10 kilometers in diameter, Styx and Kerberos. And so, so basically we are beginning to see more of the reality of Pluto, with this mission. And now, coming back to the figure we were looking at, this yellow line is the path that a New Horizon has and is continuing. And just like past missions, I'm sure you have heard that the Voyager 1 and Voyager 2 missions that did, lots of astronomy, took lots of astronomy pictures and stuff in the late 70s, have now reached the outskirts of the solar system in a region that we are also very much interested in understanding, which is the end, the solar system, and entering that interspace, between our sun and other stars. And so basically this mission, this New Horizon mission, is now continuing, has been extended to keep exploration, and will hopefully give us some more information about that region. One recent finding was this object originally called Ultima Thule and then now renamed Arrokoth, which is this very, very odd object that looks like a combination of 2 objects that got glued together. And so we are also very much interested in studying this, because these are truly leftovers of the creation of the solar system and untouched. Okay, and so they can give us more understanding of the how things were, right, after the formation of the solar system. While the planets, like our own planets, has been, changed so much by impacts and plate tectonics, etc. These are unaltered, remnants of the original objects that formed the solar system. And here is a table I found, is only to 2020, that shows kind of a timeline of objects that New Horizons has been looking at. And the way they are proceeding, the mission is proceeding, that they use large telescopes like the Hubble Space Telescope to identify possible targets. And then with whatever amount of fuel is left to redirect New Horizons, to explore in particular that region where some objects have been spotted. And as far as, this year, basically, we know that New Horizons we should be able to operate through the mid-2030s or maybe even a little longer, and is traveling at about 3 astronomic units a year. And so, as I was just saying, it will likely reach the edge of the solar system and explore also, this boundary with interstellar space. I was just reading a short question and answers on the Astronomy magazine that mentions that what about using New Horizons to scout for planet X, planet 10? And the people responsible for the mission say, no, we don't have the possibility to do that. So they will be happy to just look for other Kuiper Belt objects that could possibly be in that region. And again, this whole story of this planet 10 is there are factions, who is strong believer in that and who thinks that is just miscalculations. And so on and so forth. So basically, this leads us to the end, in which I put this big question mark. So come 2030 or 2035 or so, what will be, the look of our solar system? How many more objects will have we found there? And so where is really the end, of this solar system? So this is kind of the message I wanted to give. I hope that it's what you were looking for, and maybe some of you know more than I do about it. So, and I'm happy and open, for questions.
All right, fabulous. Yes, do we have any questions?
I have a question.
All right, Dale.
It seems to me, people talk about Voyager 1 and Voyager 2 having reached the edge of the solar system, but what about the Oort cloud? That's part of the solar system, right? And that's way, way out there.
Yeah, yeah. I mean, there is more than meets the eye, correct? But of course, these objects, I teach also introductory physics, and I always bring some of these examples to my students. These past missions, and this will be the same for New Horizon at some point, they are continuing by inertia. So it's no longer possible to deviate their direction. They have used up their fuel, and now they are in a region of space that is sufficiently far from, the masses of the sun and the planets that it can continue forever and ever. The main thing will be how long will we be able to keep contact, with the instruments. But other than that, these objects will drift in space forever and forever. and so go a long way. And so in order to look around the Oort cloud, it would be a much different type of mission that would we would have to have. And once again, because the orbits of these objects are so huge, it doesn't make sense nowadays. We don't have sufficient speed in to to go and scout this region. Maybe I don't know if it can be looked at in other ways, just like we are studying our Milky Way galaxies from inside. Maybe we can somehow, some way, make discoveries in this Oort cloud. But my belief is that these objects are so small and so far that it's not going to be an easy target. I don't know, am I answering your question?
Yes.
Okay.
I think, Dr. Parton, I would point you to, we had a short presentation last summer by one of our most brilliant members who talked about what the edge of the solar system is. So I would refer you back to that presentation for more about what the different definitions of the edge of the solar system are.
I have a question.
Yes.
You mentioned, Doctor, that that you had an issue with pushing objects out of their path, and you mentioned Jupiter, and I've heard that before, that Jupiter doesn't do it either. And you said there's another reason for that. What is that reason?
Sorry, say again.
Again, Jupiter, one of the requirements of being a planet, you had to be able to push the objects in your way out of your way.
Yeah.
And you mentioned briefly, and I heard this
Yes,
before.
Jupiter. Yeah. I think I forgot. I think it's a Lagrangian. I don't remember. It's a particular mathematical formula. So in the case of Jupiter, it's not that it has scattered debris along its orbit, but it has these two, series. Let me see if I can find it. These two groups of debris that are stable at, okay, it's coming. No, I passed it.
You'll find it.
Oh, there it is. Okay. These two are locked in gravitationally with Jupiter, and they are constantly 60 degrees ahead in the orbit and the other 60 degrees behind in the orbit.
I see.
So it's not that as Jupiter moves, it will ever encounter any of these.
Okay.
If you follow these lines, they kind of slice, that there are 60 degrees. I don't remember exactly the mathematics, but I had studied it at some point, but I don't have exact memories. But basically it's not that there are random objects along its orbit.
Okay.
Because Jupiter is the largest and has such an enormous amount of gravity, it has created this resonance, these locked groups of objects that are forever and forever.
All right.
Could I just say one thing? Actually, so the Earth's Lagrange 3 and 4 points are currently, I think, unoccupied, but the James Webb Solar Telescope is actually going to be inserted into orbit at the Lagrange 4 resonance point. So it's going to be following us in our orbit.
Thank you. You're right. Yeah, those are totally stable locations, basically. And so That's as much as I remember.
We also have a question from Greg Frederick.
Yes. I understand that when one of the Voyagers got toward the, I believe it's called the heliopause,
Yes.
it detected an electron burst, which I guess was not predicted that they would experience that. It has something to do with leaving the influence of the solar wind of our sun
Yeah.
and being affected by interstellar winds, I
Yes.
guess.
Yeah. Yeah.
Did you anything?
I'm not an expert in
Oh,
in
okay.
that.
How about the Oort cloud goes what? I don't know if I'm correct on this, but I know it extends quite a ways out to, say, the next star system. It's like a third of the distance to the next star system or something like that. Is that
Yeah, I
true?
mean, 50,000 astronomic units is huge. 50,000, the distance, you know,
Right.
Earth to the sun, it's enormous. So it's objects that have been scattered and, you know, somehow are still, you know, connected, you know, gravitationally. So,
Mm-hmm.
I mean, you know, I wouldn't know what to say about that. I mean, clearly, we would be interested in studying more of that. But
Okay, thanks.
And we have a question from Riyadh.
Yes, I have a question about Pluto. Basically, for about 76 years or so before it was demoted, it was all of humanity understood that it was a planet.
yeah,
I understand all the reasoning behind why it's been demoted, but couldn't we have just simply grandfathered it in to keep it as a
yeah.
planet, while everything else, with the new understanding, will not qualify as such?
That year, I actually gave a talk to the honor college at Oakland, you know, students at the honor college, and I told them that it made me feel almost like cry that this planet, that, you know, it has been a planet, you know, forever. So now all of a sudden, this and it was like a blitz, you know, by these people. When I went to read about, you know, the story, that it was towards the end of the meeting, and many people had left, and then a group, you know, kind of decided for everybody, you know, that this was it.
I heard that.
And I find it, you know, I mean, yes, I mean, as we are discovering more and more of these objects out there, you know, but at the same time, I find it, I don't know, personally, you know, this definition of dwarf planets. So just leave them, you know. So at this point, just leave 8 planets, and everything else are non-planets, correct?
I've heard
Redefining everything this way, honestly, I don't know why.
I heard an alternative decision of why they did it is because they were finding objects that were similar in size to Pluto, and for kids who try to memorize the planets of the solar system, to memorize 8 or 9 is fine, but when you get up around 20, you know, that may be difficult to do, and I heard that may be the driving force.
I don't know. I don't know, but
if I can comment on that, I think there's some truth to what Ken Burton just said, because historically, back in the 1800s, when Ceres was discovered, it was called a planet. And then Vesta was discovered, it was a planet. And then some more were discovered, and all of a sudden we're getting too many planets, and you can't ask school kids to memorize that many planets. And there was a perception that this is a different category of object. There's who knows how many of them in this belt of star-like objects. Asteroid means star-like. So they demoted those planets, and I'm sure there were kids who had learned that Ceres and Vesta and others were planets who were unhappy for a long time, right? But then the memory of, everybody died who was in that category. Now we're doing it the same thing again with Pluto.
Yeah.
And I also feel that they could have grandfathered in Pluto. I mean, I would have been happy with that too.
Pluto has a heart.
Yes.
Yeah.
Pluto also has a beloved. So many more
Yeah.
people identify with it some way, shape, or form.
While we're having a Pluto Love Fest, which I do approve of, we do have one more unanswered question in the chat.
May I just there's one thing I'd like to bring up about the IAU definition, and that is that the IAU definition is very specifically about only our solar system. It specifies objects that orbit the sun, so it doesn't apply outside our solar system. And so, as such, I think it's better to think of it as a tool for having discussions in papers and for having a lexicon, but it's not so much a scientific definition, because scientific definitions don't encompass only one solar system. So
Yeah. And they are finding, strange things like Jupiter-sized planets very close to a star. So we are discovering lots of other stuff that will probably change, our view of planetary systems, etc. But, for the moment, I don't know, I guess we accept what it is and move on, just more than focusing on these definitions, focus on the search, for new objects and the beauty of astronomy is that we continue discovering something new, and that's what we should be focusing on.
So Jeremy Veldman asks, the sun is 99.86% of the mass of our solar system. Does that include the Oort cloud?
I would imagine so. I don't know that we have a complete estimate of the mass of the cloud, because once again these objects are so light that they will not really alter by much the mass of the solar system. These are chips. So the density of mass inside the sun is overwhelming compared to these objects. We saw before that even the asteroids, the overall mass of the asteroids is estimated to be 1/1000th of the mass of the Earth, which is pretty much nothing, compared to the mass of the sun. So even these comets that are dirty snowballs, pretty much, they must, be very light. So however many are there, they are not going to contribute in any major way to the mass of the solar system.
All right, and Greg Frederick comments, most solar systems are not like ours, which is absolutely true.
Yeah.
Jeff McLeod adds, most we have been able to detect, but systems with long period orbits are hard to detect. Jeff, do you want to elaborate on that at all?
Just that my understanding, I mean, if you're using Kepler with the transit method, it has a hard time with long period orbits. And then if you're using a gravity type, looking for oscillations in the spectrum, again, it's there, for a system like the solar system, it's pretty minor. And so anything that's like long duration is going to be really hard to detect. So I'm not saying with any definitiveness, but I was always told that it's just hard for us to really know how common a place like home is elsewhere in the galaxy.
Mm-hmm.
Yep. Excellent. Do we have any comments that came in on YouTube? Or questions, rather?
Sorry, that was it so far.
All right. Any more questions? Well, thank you very much. I know all of our Pluto still excites some pretty high passions here in the club. I count myself in the yes, they're all planets. Learn 36 planets if you have to camp. But yeah, but thank you very much for joining us tonight. It was great to be able to have you
You're welcome.
Come talk to our little club. All right, everybody, you can hang out in the chat room. Snack time. And don't forget, if you want a replacement calendar, let us know by the Macomb meeting. And that concludes our official programming. So just kick back and have a good time, y'all. Thanks again.
Take care. Thank you.
Thank you.
I'm of the opinion that Pluto should be grandfathered in. I think so. So does it only fail by the third criteria? It hasn't completely cleared its orbit?
That's exactly it. It's the only
exactly
criteria is the only one that disassembles it, if you want to call it. It is small, though, but again, what's small? You know, if you're a sphere, you're pretty big. So.
Yeah.
Well, Pluto orbits the sun.
Right.
And Pluto, it looks spherical. So it passes the 2 out of 3 criterion. It just is part of this Kuiper Belt. So it has not cleared its orbit.
Right. But again,
something else sort of weird about Pluto that wasn't mentioned is that since its largest moon is so large,
it's a double planet.
It's a double planet, and the center is actually outside of essentially the planet itself, the center of gravity. So they sort of wobble around each other in a sort of binary pair going around.
Although, so it is true. It's the barycenter is way outside the sphere of Pluto.
Right.
But Dale, I do want to point out that the barycenter of our solar system is pretty regularly outside the sphere of the sun, and nobody's saying that the sun isn't our star. So
I think Jupiter's center of gravity with the sun is outside the sun's surface. Jupiter's, I think.
One of the anti-Pluto arguments is what would happen if Pluto migrated in towards the inner part of the solar system, and the fact that it may develop a tail and look more like a comet.
Well, I think it's a little bit too big for that, but that's okay. It's a possibility.
Yeah, I mean, I think if the Earth was to move closer to the sun, we would develop a tail, and we would look like.
Yeah, I mean, what did Mars look like when its atmosphere was actively evaporating off?
Yeah.
If we could go back in time and see Mars, what kind of tail would we see on it?
Yep.
There you go.
I say if you're more than 5 degrees off the ecliptic, you're out.
Well, there it is.
So I want to point out, Neptune has not cleared its orbit because Pluto crosses it.
Yeah, exactly.
Well, speaking of that, I guess I didn't understand the answer regarding the Trojans around Jupiter and how that. I forgot who asked that, but I didn't understand the answer either. What does the definition, the third definition or the third requirement actually mean to clear its orbit?
Well, Jupiter doesn't, but there's an interesting dilemma that is pointed out that's actually the Trojans that are spun off from the asteroid belt, and that's why they're permanent in their position. So Jupiter doesn't actually clear them out, but it's a special situation for Jupiter. That's the explanation.
I think the Earth has Trojans too, right?
Yes.
True.
So, what does the phrase "clear the orbit" mean? If the orbit isn't clear,
they wanted to find a reason to dishonor Percival Lowell. That's what they wanted.
I mean, so at least you could say that since the Trojans, like the Trojans are stuff that is essentially caught in, gravitationally, an equilibrium point. It's an unstable equilibrium, but it's still an equilibrium point. So they their motion through space is completely controlled by the larger body.
Sure.
You could consider that being, not the same thing as random junk. But again, the Earth has a bunch of meteor showers, which you can see
Absolutely.
in this calendar.
Sure.
And those are not from clearing the orbit, and those are from periodic comets that are crossing our orbit. So
And what is there?
that
41
definition
of them?
just doesn't resonate with me.
And
I'll
there's,
say.
what are there, 41 meteor showers a year? Actually, 41 of them? So come on, really?
Well, notice that
Maybe it's the fact that they don't destroy, not all of them can destroy the Earth destroys them. So it's clearing the path.
Nice.
Well, I mean,
something hits Pluto, it probably knocks it into a different orbit. I don't know.
So Pluto's orbit is so long, the duration, maybe it just hasn't gotten around to it yet. Maybe it needs a few more 100,000 revolutions to clear off some of those icy bits.
Yeah, well, again, it hasn't really moved very far.
And increase its mass enough, to.
I think people are really rushing it. Like, people should give it a little bit more of a chance.
I think you're
They
right.
should have written the rule as just that it couldn't be in a belt.
That that at least would be a simple, straightforward rule, and because to me, Ceres is still a planet.
Yeah.
I tend to agree.
But and nothing else in the asteroid belt is, but Ceres is because, well,
it's a big sphere.
What's really funny, I was talking about this with a friend of mine the other day who is an ornithologist, and in the biological world we have this Linnaean classification, which is all about genetics and all about the lines of inheritance that these different creatures have, and so we don't group animals based on how they behave or how they look or how anything about their behavior. We only group them based on how they formed, basically.
Okay.
And I was saying with planets, it's the opposite. We only talk about planets as to how they behave, because we don't have, as a rocky planet, we don't have anything at all to do with Jupiter or with Saturn. We were formed through matter collapsing into a sphere, but that's it. Like, in terms of the actual chemicals, in terms of the actual geological processes and the future life cycle, like, none of that is similar between us and Jupiter or us and Uranus.
Mm-hmm.
And so, like, it's just very different. It's funny that different branches of science took completely 180 degree or 90 degree different approaches to similar questions.
So it took a long time for biology to get there.
Yeah, it's true. Too.
Yeah, I mean, they have a different means of doing it, where it's a lot harder. I mean, we don't think that there's an evolution between an Earth-like planet towards something like a Jupiter-like planet, or vice versa. So, and you can't give them a swab test, which I used to say in my planetarium shows. There's no test you can give that just comes back planet yes or no. It's a definition that we just like to make.
The funny thing is that we actually have an evolutionary classification of sorts when it comes to stars, because we know that they do change.
Mm-hmm. And like Pluto has a very nice nitrogen atmosphere. It's cold there and everything like that. But again, if you want to compare, what is a planet compared to what another planet is, really? So does atmosphere have anything to do with it? I don't know.
So other than since it's been discovered 80 years ago or whatever, Eris is about the size of Pluto and round, and I think it has a satellite. So I mean, wouldn't it have similar? It doesn't have the history, of Pluto, but it really has just as much justification, certainly, of being a dwarf planet. But if in fact Clyde Tombaugh had found Eris rather than Pluto, we would have Eris as our ninth planet, and all the kids would know about that.
There you go.
I mean, yeah.
But he would have called it Pluto.
He would have called it Pluto. Pluto would, would have been a small dot way out there that,
well,
New Horizons, we probably wouldn't really know what they would look like.
I mean, Pluto is the biggest, and it's only the biggest by a hair, but
yeah.
If you take all of the different bodies, it's the most massive. The only reason that Eris is more massive is that Pluto's mass is concentrated into all the moons, but
well, and keep in mind that at the time Pluto was discovered, it was thought to be closer in size to Earth. It was quite decades before it was realized how tiny Pluto actually was.
Actually, it was measured. It was supposedly measured at larger than Mercury, somewhere in the range of 3,500 to 4,000 miles in diameter, because we couldn't resolve Charon. And that didn't. That's what. When did that occur? When they finally figured that out?
It was like 77, 79, something like that.
When I was growing up, we thought that Pluto was larger than Mercury.
Pluto was larger than Mercury, but it was two objects. So there you go. It's very interesting.
Being friends with Mickey Mouse helped tremendously.
Well, the name came. The two reasons for the names. First of all, they wanted a Roman god, so Pluto was the god of the underworld. Okay, and being out where Pluto is probably is like a hell. And they also named it Pluto for two other reasons. Pluto matched up, like I said, with Percival Lowell, who actually predicted its finding, and PL is in honor of him, really. That's why they selected that. And some school child decided, I think it was a British child as well, and they said, why not Pluto? And then they went through all of it. And of course, Pluto was becoming a cartoon right about the same time. So, everything kind of fit in. So it's an interesting story about Pluto itself. Percival Lowell was absolutely positive that it was there. And Clyde Tombaugh just found it by luck, is what he did. Because the perturbations in Neptune's orbit are actually caused by Uranus. All right. And then they've discovered since then that Uranus is the one that's affecting it, not Pluto. Pluto's too small.
Actually, I've met Clyde Tombaugh a couple of times.
Did you?
And he would probably disagree that it was luck. I think he would say it was perseverance and very, very, very hard work.
No, but I'm saying is that wasn't what he was trying to find. What Percival Lowell had predicted,
Planet X,
because of the gravity, but he found it because of his diligent work. There's no question about that.
I disagree.
Why?
Disagree.
You think
I heard Percival Lowell speak in a big auditorium in Mount Clemens.
Okay.
And
Percival Lowell?
No. Clyde Tombaugh. I'm sorry. Sorry. And what he said
died in
is
1915.
Somebody else had built the equipment that he used to find Pluto and had gotten tired of messing with it. And so they hired Clyde Tombaugh to run that experiment, and he found it in no time by pure luck. It was within a couple of months. He said he then spent the rest of his life trying to find another planet and never did.
There you are. You hit it.
So it was luck that he found Pluto. I have a different question. Jonathan said that this new definition of a planet only applies to our solar system. Where did you get that idea?
I posted the link to the IAU Word document that is the official definition. I'll post it again in the chat.
Because I just Googled it, and there's a NASA website which says, it lists the three things. It says it must orbit a star in our cosmic neighborhood, the sun. What?
Nope. I just posted the link in the chat if you look there. In fact, I'll put it on the YouTube channel too, since you're still broadcasting there. But that is the IAU.org official definition.
Yeah, I was just there looking up the clearing of the orbit, and I read the very same thing. It is just for our solar system.
Everything else is an exoplanet.
Yeah, everything is an exoplanet. If they found Pluto around another star, it would be a planet.
I mean, there are textbooks. There are textbooks that generalize that definition to a planet orbiting any star.
Right. Okay.
It's just not official yet. The
But that's
IAU
not a
doesn't-
definition.
Right.
That is not what the IAU voted on.
Yeah.
The
Well,
IAU voted on a specific definition, and the definition only applies to our solar system.
There was
Okay.
even a comment about what if a planet from our solar system somehow got kicked out of the solar system? Would it still be a planet?
Like Space 1999?
Yeah, there you go. Well, that was the moon, right? But
Right.
But then the answer would be no. It's not. Well, it's not a planet because we don't really have a formal definition of a planet outside of our solar system.
so you have a rogue, supposedly a rogue planet wandering out there, which if there got to be plenty of them, what are they called?
Well, rogue planets until somebody defines it officially.
I mean, what would you call them? I know there's a lot of. What about this Planet 9 they're talking about now in the web? If it
I
ever
think
gets up.
I think the technical term is SOL, Ken.
Yeah, I know. I get it. I agree.
Does the IAU even have jurisdiction over the solar system?
Yes.
I mean, they're international. They're not interplanetary.
The only thing that has
Till they make contact.
There's the only thing that has jurisdiction over our solar system is our sun.
What about Mr. Universe?
Right. Yeah.
Notice how they did that. Basically, they waited for most people to leave that meeting before they did it. This is what politicians do. Because they knew that people will object to it.
Yeah, of course.
They already had their new books written, and they wanted to sell the new books without Pluto. So,
well, I'll tell you what. You know some names that you might not have known. You know, you might have known them, but some people definitely increase their speaking fees by being part of kicking Pluto out of the club.
Neil deGrasse Tyson.
I was thinking more Mike Brown, but both of them, I would say.
Tyson says Pluto's not a planet. Get over it. That's what his thing is all the time.
He's the one that talked about the whole Pluto really being a comet thing, and
right. Yeah,
starts
I
off
heard
his
that
talks
too.
with that.
Well, it was Mike Brown who really led the charge to kick it out.
Really?
And
Okay.
it's also Mike Brown who is the one purveying these stories of a planet X that only he can see. So, you know, I am exceeding my FDA recommended allowance of salt whenever I hear about Planet X. But
well, supposedly the James Webb would be able to see it if it's there. But there's something there, and it could be just a mass of stuff. You know, not just a big planet. But when the Webb goes up, you know, sometime around 2035. Finally, it's probably going to be able to see it.
We'll be able to see it and determine if it's a comet.
Yeah. Now, again, if they find that out there, I would suggest if it's big enough, it's a planet. You know, I guess.
Well, either way, I guess there's someone commented that I listened to that said, well, we do have a term for all of these things. We call them all worlds. So why not just be happy that they're all worlds?
Yep,
that's good. Works
I think Emily Lakdawala is one prominent proponent of that way of looking at things. I like that definition. Like, if there's something going on, if there's an atmosphere or the ingredients for an atmosphere or interesting geology or any interesting electrical effects, like that's the stuff that's interesting to me. Like the orbital stuff, that's just what happened. It could have happened a million different ways.
And
so
Pluto
I don't
is
know why people are so obsessed with it.
Pluto is just a magnificent object for all the things they found out about the no cratering and a nitrogen base and all this other. It's really cool.
Yep.
It's really cool.
No, you look at a picture of that and you just, just one photo is 1,000 questions, 1,000 different PhD dissertations,
right,
in the making. So,
yeah, it's cool.
I have a question. The New Horizons spacecraft, have any objects been detected that it could be steered to, and is there a plan to do so?
As far as I know, not yet.
No, but they still can. That's the deal.
Yeah, they still have some fuel, but they're still hoping that they'll get some choices. But as far as I know, right now they don't have any firm targets in mind.
Right.
Now it could spin around to point its camera to maybe get a sort of a local view of something.
I would.
Its camera really isn't set up really the best for that sort of thing, right? Yeah.
There's a possibility. They're working on something, and I'm sure.
So they can't do a new pale black with it?
You know what? I think that they actually said. In fact, our presenter, I believe, I read the same issue of Astronomy magazine. And I think Alan Stern had made some. I seem to remember seeing that that they were interested in doing that, but so far things hadn't aligned to be able to try to do that. But I thought that was, maybe I'm thinking. You know what? I'm thinking of the Mars rover. Never mind. Yeah, I don't know if they can see Earth from there with the instruments that they have.
Don't know. We'll see.
Yeah, Dr. Wien said they could image the crescent of the Earth with the rover they have on Mars, but they're scared to point it in the direction of the ecliptic.
Right.
Because of burning out the lens that you see for the sun, or what?
He said if they point it, the Earth is roughly on the ecliptic.
Right.
And if they point at the Earth and focus on infinity so they can image the Earth, and then the rover freezes up for a day or so, then the sun would drift across its point of view and possibly blow out the sensors.
Yep, that's what I heard too. Yeah.
So they just don't want to take the chance on doing it.
I got it. But it'd be a great story, wouldn't it? Be great.
Maybe closer towards end of life, end of mission. They might feel the risk is worth it.
Yeah, I would think that's possible too.
They should have sent it up there with your lens, Dale.
Yeah.
If it burns that camera out, then oh well. But only so much payload you can take with you on a mission, so the extra lens could put it out of commission. I guess make it too heavy or something.
You know what? I think all future missions should have a rear view camera, backup camera installed. Yep. They can always take a picture back towards Earth.
Yeah.
Wow. I can't remember if Dr. Wien said it in this presentation we heard, or if it was in the previous one I heard him give. But he had to really fight to get a microphone. I mean, a microphone on this SuperCam instrument. It can't just be, we'd like to hear neat sounds on Mars. It had to have a scientific purpose. So when they found that they could get information about the hardness of rock by the sound a laser pulse made when it hit it, that's what it took to get the microphone. And a microphone is a tiny little light thing compared to another big 110 millimeter aperture telescope.
The Russians put a microphone on their Venera missions that went to Venus. You could actually hear sounds of, the winds and whatnot on Venus.
About that.
And Russians are notoriously cheap.
We're not much better.
Hey, the Russians sent missions to Venus. We have not. I mean, we only had the one. We had.
We never landed.
Pioneer multi-probe, and that's the only thing that's ever gone into the Venusian atmosphere.
Yeah, we never even attempted to land anything there.
We did, but only the Pioneer multi-probe, and they didn't think. Only 2 of them made it down while still alive, but we didn't expect them to. So.
Yeah, nothing lasts long there.
Not at 850 degrees.
No, you can melt lead. Extremely high pressure.
Yeah.
Sulfuric acid in the atmosphere. It's hell.
Is that all? I'm waiting on you to tell me something that'll actually do some damage. Sulfuric acid, nah. 850. What was that? The pressure when you actually get to the surface?
90 times the Earth's pressure.
90 times the Earth's
90
pressure?
times. Yep.
So
90
tipping
times.
Hot sulfuric acid will even dissolve gold.
Yeah, that's what I heard.
Well,
yep.
This isn't made of gold, so okay, that's good. So what else? You got all the lava that's on the surface of the planet, all the volcanic activity if you do survive.
Yeah.
And there's storms on Venus as well. There's electricity going along to add insult to injury, right? And aren't there high winds? Aren't there high winds on Venus? In the upper part of the atmosphere?
They're up around 250, I think. About that.
250?
Somewhere to 250. Somewhere at that range. Somewhere.
Well, with that air density, a low wind is pretty strong.
Absolutely. That's the point.
Yeah, so did you know that the Russians actually had balloons that covered about a third of the circumference of Venus? 2 different balloons
Didn't know
with
that.
the Vega missions.
Really? Wow.
So they were whipped around 2/3 before something got them.
Well,
Surprised
1/3,
they weren't
but yeah.
melted by the sulfuric acid.
I think they're above, honestly, the upper cloud tops of Venus are one
Not
of the
bad.
nicer places to go in the
Not
solar
bad.
system.
Sightsee. That's what I've heard.
Didn't some missions say they detected possibility of life
Yeah, that was
in the upper atmosphere?
Well, they detected phosphine, but the
right.
phosphine, the instruments weren't really calibrated for that.
Right.
So while they did find an unusual amount of phosphine, it's by no means conclusive evidence
Right.
that there's any sort of life there. It's just interesting.
But we need to go back. The only thing there is Akatsuki, and Akatsuki is literally half dead. So by the time it got into orbit, it was half dead because things went very. They salvaged a triumph out of tragedy, but it would sure be nice if we could send some kind of decent probe to the planet that is most like ours in the solar system. You would think that would be interesting to people. I don't know.
Except for all of those minor things that destroy anything we know how to build.
Yeah,
well,
solar probe.
Everything dies eventually.
Yeah. Well, I mean,
It'd be easier to actually explore Mercury. Mercury is closest to the sun, but less harsh, right?
Right. That's harsh. But of course, there's virtually no atmosphere there. So
yeah.
It's also expensive from a propellant standpoint to get to Mercury.
Hard to orbit it.
A lot of potential. A lot of potential.
Well, as soon as we develop something completely indestructible, that's when we send it to Venus.
Well, not necessarily. I mean, if we send a probe that can bring back a sample of the upper atmosphere, I mean, that may be something.
Could be.
That would be a good start. That would,
I think,
determine habitability, I think.
I just think the 2 places we want to send something to get there and be there is Titan and Europa. Those 2 places I'm really excited about.
Enceladus.
We would have,
Enceladus
we'd have to terraform those places, but I suppose it's possible. We turn
Enceladus
it into
is also
miniature.
something.
I think NASA is planning on a probe that will orbit Jupiter and do flybys of Europa in the near future, if they get the money, of course.
Yeah.
They're going to do flyovers because the electromagnetic radiation from Jupiter is so intense they can't stay in that atmosphere around Jupiter too long. They have to fly in and out, and then pass Europa.
So they have to plan the way.
Right. So they don't fry the whole ship.
Isn't Europa tidally locked? Couldn't you land on the...
They're all tidally locked.
As far as I know, yeah, they're all tidally locked.
They're all tidally locked.
So if you land on the opposite side of Europa.
Well, this isn't a lander; it's just gonna fly by.
But again, if
this wouldn't be the mission to land on that side.
No.
you got to have something that's going to burrow through that ice. We don't even know if it's spiky or not. Or we had enough trouble trying to put something on P50, whatever it is, the
67.
comet.
Yeah.
67. Sure, Mesto Fragabaca. But anyway, but I think that they need to get something that's going to burrow down into the water of that moon and search around. I think they're going to find some interesting stuff.
Well, it's what, a mile or more of ice, except there are cracks, so it could be thinner
Yes.
there.
Yeah, I
there
think
too,
I
but
think
again-
burrowing is the wrong way to go. The ice
Yeah,
is, last I read, is many miles thick.
Yeah, might
know,
be like
so
5 or so miles. I'm not sure.
Let Europa bring stuff up to you. That's the whole idea of the mission.
Works for me.
There are cracks and stuff comes
Geysers,
flying up
I
out of those
think.
cracks. So you don't have to go down to the liquid. It'll come up to you and you just fly through it.
Okay, works for me.
That's what I
But
think they are expecting, possibly
Okay.
geysers, yeah.
And the idea is the time it would take the stuff to fly from the surface of Europa to the spacecraft is like, I forget, a second or less.
Really? Okay.
So its exposure to radiation is very low because it's out there such a short time. And then the compartment in the spacecraft that the stuff is captured into has fairly dense and thick surroundings to protect it from radiation while it's being analyzed, if I recall correctly.
So if they time it perfectly, they could capture the ice water mix or whatever it is coming from Europa and capture it as a sample.
Yes.
Then bring it
You
back.
don't, that way you don't have to land on the moon. You don't have to loiter in the high radiation environment.
Cassini did
You don't
that.
have to drill down through miles of ice.
Right.
Right.
These would
Cassini
be
did that with
major
Enceladus.
challenges.
Yeah, but it never got the chance to bring any of it back, unfortunately. I
No,
know
they
it's-
analyzed it there.
Yeah, I know they analyzed it. If you bring it back, then you can put it in a bottle and sell it for about $2 million and see who drinks it. Of course, that wouldn't be good for science because we'd need it under a microscope and not, inside.
They're talking about the water there. If there's water there and such, and that ice, it's a little. There's rust all over all over the moon as well, which is means that that it's probably a saline solution, is what it indicates. What's that?
Looks like the building blocks of life are there.
Yeah, there's no question. That's why I find that just to be a fascinating place to go.
Yeah.
But anyway.
All right.
Well, good night.
All right,
Good night,
Dee.
all. It was good seeing y'all.
We'll see y'all.
Great,
Good night.
great meeting.
Good night.
Great meeting tonight. Really great.
Yeah.
Have a good night,
Yeah.
everybody.
Bye,
Be
Diane.
safe.
Bye. Good night.
Bye.
Yeah. Yeah. Yeah.
Bye-bye.
I'm leaving. Goodbye.
Good night.